So in this lesson, we will be doing some gas stoichiometry. So first, let's go ahead and review what stoichiometry is. So stoichiometry, remember, is able to relate the amount of reactants to the products and vice versa depending on the mole ratios or the coefficients right here. So this is a 2. That means if you have 2 of H2, you will make 2 water molecules. If you have 1 O2, you will make 2 water molecules. Okay, so if you wanted 4 water molecules, you will need, this is a 1 to 2 ratio, so you will need 2 of these. Okay, so these are the moles or the number of molecules. Okay, so you can relate them to each other, and if you wanted to go to grams, you can convert that to grams. And if you had grams over here, you can convert it to moles and go use the mole ratio. So here's an example. If you had 6.50 grams of aluminum, you go to grams to moles, and then you go mole to mole ratio, and then go to Al2O3, and then you go to grams. And here's the conversion here, and you see the mole ratio right there. Okay, the problem is with this type of stoichiometry, if you make a gas molecule, let's say you're making a hydrogen gas, it is very hard to weigh it to compare what you're supposed to get. So what we have to do is instead of going from moles to grams here, we have to plug it into PV equals nRT to get the moles. Okay, so let me show you what I mean. So here I have a combustion of C8H18. So combustion means burning. So I'm going to be burning C8H18. To burn that, I'm going to be mixing it with O2 gas. And what's going to happen here is carbon will be oxidized, and it'll make a very stable product, CO2. Or hydrogen will also be oxidized and mixed with oxygen, and the most stable product with H and O is H2O. So in a combustion reaction, you make CO2 and H2O. The next thing you do before you do stoichiometry is to, what do you think? That's correct. You have to balance the equation. So I'm going to do a quick balancing here. There's 8 carbons. You have 1 carbon here, so put an 8. Okay. You have 18 H's. You have 2 here, so put a 9. Now you have 18. Now the O's I always do last. 8 CO2s will make 16 O's here. 9 waters will make 9 O's here. 16 plus 9 is 25. So I need 25 here, so I would do 12.5. 12.5 times 2 makes 25 O's. So that's balanced as well. Okay, next thing I'm going to do is double everything because I can't have a 12.5 there. So this used to be a 1. I'm going to double that to 2. This becomes 25. This becomes 16. And this becomes 18. Okay, do a quick check. 16 carbons, 16 carbons. 36, 36. 32 plus 18, yeah, is 50. Okay, so that balances out. So my balanced equation, I'm going to rewrite it here. C8H. So I rewrote the balanced equation. Now I'm going to read the problem. If you start with 15 grams of C8H18, I'm going to put a box around here just to organize my data. So you will put the givens underneath where they belong. So you have 15.0 grams of this. C8H18, okay, this is this. How many liters of CO2 gas? So this is what you're looking for, question mark, liters, will you produce in this room? And this room is 1 ATM and at 23 degrees Celsius. So what I'm doing is I'm putting all that information underneath the gas that I'm producing and underneath where the question is, okay? So according to stoichiometry, 2 moles of C8H18 will make 16 moles of CO2. So what I will do is I will change this to moles, and using the mole ratio to the 16, I will be able to get to the moles here. okay? That will give me N, which is moles, okay? Then what I will do, once I get N, I will plug it in to an equation, because here I have T, I have P, and I'm looking for V. How do you suggest I get the volume? That's right. Instead of doing grams to moles, which you would do here in this part, you will stop right here, get the moles, and then plug it into an equation that has all of these variables, which is PV equals nRT. This is the ideal gas law. Okay, where R is the ideal gas constant, 0.0821 LATM Kelvin mole. So you have all of them but the V. Okay, so let's begin. So I'm going to have 15.0 grams of C8H18. Okay, and I'm going to go all the way to moles. Please pause the video and do this yourself. Okay, so you're going to drop the undesired unit, which is grams, C8H18. I'm going to go to 1 mole of C8H18. I'm going to show my work over here to get 8 carbons and 18 H's to get the molar mass of that. Okay, 8 carbons I calculated to be 96.08. That's 12.01 times 8. Okay, 18 carbons, I did 18 times 1.008. I got 18.14. Okay, I have 4 sig figs. 4 sig figs, when I add them, 12 carry 1, 14 carry 1. I'm going to have 2 decimal places. I'm going to have 5 sig figs, but 2 decimal places. That's what's important. So that's 114.22. Okay, next I'm going to do, so I just went to moles. I'm going to moles of the other substance. So moles of C8H18 and to moles of CO2, because that's the question. Okay, now I'm going to use the mole ratio, which is 16 on the CO2 and 2 on the C8H18. Okay, go ahead and plug this in the calculator and get an answer. So I got 1.05 moles of CO2. Okay, now that I have moles, I really have N, okay, which is right here is what I'm looking for, right? So now I'm going to use PV equals nRT to find the desired variable, which is they want the volume, and they want it in liters. So I'm going to write the pressure, which is 1 atm. That's P. V is missing. That'll be my variable. N is 1.05 moles. R is 0.0821 LATM Kelvin mole. And temperature is 23 with no decimal places plus 273. I'm not going to use the decimal places. I don't need it. 69296. 296 Kelvin. Okay, to solve for this, I'm going to divide both sides by 1 atm. And plug that in. 1.05 times 0.0821 times 296 equals 20, divided by 1 equals 25.5. You know what? I think it's better to use the number here. So I'm going to start here again. I'm going to do 15 divided by 114.22 times 16 divided by 2. I got 1.0506. I'm going to keep that number. That number's here. Leave it in my calculator. Times 0.0821 times 296 divided by 1. 25.5. Okay, same thing. Okay, now the units. So I have moles canceling, K's cancel, ATM cancel. So now I have liters, and this is the liters of CO2. And this is your final answer. Okay, just a recap. If you start with a certain mass of this fuel, this is octane, you're able to calculate how much CO2 you can make. You can predict how you can make. And because it's a gas, you can't really weigh it. You have to get it in a certain volume, right? So then the volume will depend on the conditions in the room. So they have to tell you that. So you do stoichiometry. You go grams to moles, stop at moles, and then plug it into PV equals nRT, and you can get the volume that way. This is a very powerful tool. And the problems in the future, they might start with volume and go to grams. So you can go backwards as well, okay? Just know that if you have a gas, you have PV equals nRT to get any variable that you need.